Hi everyone and welcome. My name is Saldina. I am a software engineer and I make programming related videos on Code Beauty YouTube channel. And in this video I want to talk about O.O.P, so Object-Oriented Programming. This course will start on a beginner basic level, and then as the course progresses we will see some of the more advanced concepts. I will explain those advanced concepts and I will show you how you can implement all of those concepts in code. You can find the full content of this course in the description of this video, so make sure to check that out. And then if you want to see some different examples, if you want to learn more C++ and you want to upgrade your knowledge, I have a lot more videos like this one on my channel, so I invite you to visit Code Beauty YouTube channel and I'm going to see you there in some other video. So let's start with this video. So the first thing that I want to explain is what is O.O.P? What is Object-Oriented Programming? O.O.P is programming paradigm, which means that it is a set of rules and ideas and concepts. It is basically a standard in programming that we use to solve a specific type of problem. Now, besides object-oriented paradigm, there are other programming paradigms as well. You may ask why? Well, we as humans have a lot of different types of problems, and our computers help us solve those different types of problems. And if one paradigm is good to solve one type of problem, for example, that does not necessarily mean that it is good to solve all other types of problems that we have. So the idea behind object-oriented paradigm is we want to be able to represent real-life objects, real-life entities, together with their characteristics, with their attributes and their behaviors. We want to be able to explain those objects to our computer and to represent those objects in our program. And that is exactly what O.O.P is used for. So how does this work on a real-life example? Let's use the example of car. So a car as an entity in real life has many different attributes, many different characteristics. And some of those are manufacturer of that car. So is that car a Volvo, a Ferrari, or a Ford, or some other type of car? And then that car certainly has a color, it has price, it has max speed that that car can obtain, and many more characteristics. I'm sure that you can think of many more characteristics of a car than I can do. So those would be some of the attributes and characteristics of a car in real life. And then some of the behaviors of a car are, for example, a car can drive, a car can accelerate, it can stop, you can open the door of a car, you can tank your car, so you can put fuel in your car, and then you should also have the option to show how much fuel that car has left. So those would be some behaviors that car has. And as I said, object-oriented programming, the idea of object-oriented programming is to be able to represent that car from real life in your program. So how do we do that? How can I represent a real-life entity like a car in my program, or another entity like a game or a sport or a student or a book or animal, So the answer to this question is by using classes. Now, class is a very important concept in O.O.P. Class is building block of object-oriented programming. And a class is basically user-defined data type. And in order to be able to understand what are user-defined data types, you first need to understand what are predefined data types, what are built-in data types. So data types like integer and float and double and character and so on. And if you are not familiar with these, I am going to refer you to my video that I made on my channel related to variables and data types. So just search Code Beauty variables data types and you should be able to find that video. And then if you are familiar with these predefined data types, I'm going to tell you that a class is a little bit more complex data type. And in what way? Well, let's say, for example, that in your program you want to represent username of your user. In order to be able to do that, you will just create a variable of type string and call it username. And you should be able to store the username of your user in that variable. But what happens if you want to store the entire user in your program? That user has many more characteristics than just username. User has his name as well, and then gender and email address, and then he has height and width, and I'm sorry, weight. He has weight, and then he also has some other characteristics, and all of these characteristics are going to be variables that have its own type. And then all of these variables together are going to make one group, which will be a class that represents your user. One thing to keep in mind, though, is that you will need to store the information that is important for your specific program. For example, if we are talking about Facebook user, then height and weight of that user is not that important. But if you are building a fitness application, then height and weight of your user is extremely important. So you should store the information that is important for your specific program. So let me show you now how we can build a class in C++ code, and the IDE that I'm using here is called Visual Studio, and you can download community version of Visual Studio for free in case that you want to follow this tutorial and type at the same time together with me. So let me show you now how you can create a class in C++ code. The class that I want to create is called employee, so let's do that now. Let's create an employee class in this program here. So the first thing is you type class keyword, and then you give a name to your class. So I'm going to call mine employee, like this, and then you use these curly brackets. And at the end of these curly brackets, you need to put semicolon, because if you don't, if you forget this semicolon, you will get a compile time error. And if I try to run this program now, that is not going to be possible, as you can see here. And it says here immediately, it says expected a semicolon. So you need to put semicolon here. Okay, now that we have created this employee class, we see that this class is empty. And what we need to put inside this class here, so inside these curly brackets, because that is the body of our class, we need to put members of this class. Now, the members of this class are going to be its attributes and its behaviors. So what kind of attributes an employee has? Well, an employee definitely has a name, so let's put that in. So I'm going to say std string and then name, like this. Okay, and then employee definitely has a company that he works for, so let's add that as well. I'm going to say std string company, like this. Okay, and I want to move this string. I'm going to include it here. So I'm going to say using std string, so that I don't need to type it every time that I'm using string. Okay, and now I can remove this. Now it looks much more readable. Okay, so far we have added a name and a company for our employee. And let's add one more thing. Let's say that every employee has age. So int age. We are going to represent age as an integer number. So as you can see, at the end of each of these attributes, you put semicolon as well. Okay, so far our employee has 3 attributes: name, company, and age. And you can add many more attributes here if you want. You can add his title, you can add his email, you can add employment date, his birth date, and so many more. But I'm not going to do that in this situation because I don't want to add a bunch of code that we will not be using, because I'm going to add that code as we need it later in the program. So this class here does not represent data. This class here represents a blueprint. So whenever you want to create an employee, this class here will serve as a model for that employee. So this class here will say, hey, your employee needs to have a name, a company name, and age. So how do you create an instance of this class? How do you create an object of this class? Let's show that now. So how do you create a variable of type int, for example? Well, you type data type first, so int, and then you give the name to that variable. So let's call it number. Okay, and with this we have successfully created a variable of type int, and it is going to be the same with a variable of type employee. So you first specify the name of that type, and the name is going to be employee. So this here is user-defined type, which is called employee. Okay, and then how do I want to name this variable? Let's call it employee1, like this. And with this, we have successfully created a variable of type employee. This here is going to be an object of this class here. So let's remove this because we don't need it anymore. It was just for demonstration purposes. So how do you access now these attributes? How do you access these members of employee class? Well, the approach would be the following. You type the name of that object like this, and then if I put dot here, we should be able to see all of these members here, but that is not happening. So why is that the case? Well, there is one rule that says that everything inside class in C++ is private by default, which means that all of these members here are private. And in order to be able to understand this and fix the problem that we have, I need to tell you a little story about access modifiers. So in C++, we have three access modifiers. We have private, we have public, and then we have protected. And let's explain now what each of these mean. Well, private means that whatever is private in your class, that is not going to be accessible outside of your class. That is basically going to be hidden. And then public means that whatever is public in your class, you will be able to access that outside of your class as well. So anyone else outside of your class is going to be able to access public members of your class. And then protected is somewhere in between private and public, and it has certain rules to it. So we will be talking more about protected access modifier when we start talking about inheritance later in this course. So for now, you need to remember that there are three of them. There is private, there is public, and protected. So in this particular situation, one rule is that everything inside your class is private by default. So this situation here is the same as if we wrote it like this. Okay, this is just explicit way to say, hey, everything beneath this private access modifier is going to be private. So this situation is the same as this situation. Now let's return our private access modifier and let's see how we can fix the problem that we have. And the problem is that we cannot access these members of our employee class, and we want to do that. So let's try to change this private access modifier with a different access modifier. Let's try protected, for example. Well, if I try to access these members, name, company, and age now, if I press dot, as you can see, nothing is happening, so I cannot access these, name, company, and age. If I try to type, for example, name, I get an error which says member employee name is inaccessible, so protected is not helping as well. So let's try the third one. Let's try public. Okay, and now, as you can see, the error has disappeared. And if I try to do this once more, we have all of these members, name, company name, and age. We have all of them here. They are offered to us. So that means that by changing this access modifier to public, we will be able to see all of these properties here. So let's now set the values of these members. Let's say that the name of our employee will be, for example, Saldina. That's my name. Okay, and then let's copy this 2 more times like this. So the company will be, let's say, for example, YouTube, and then Code Beauty, which is my channel. Let's say that that is the company that I work for. And then age. Okay, age is an integer variable, so we are going to set it as an integer, and age is going to be 25. Okay, so with this here, we have created an object of type employee. That object is called employee1, and here we have set values for the properties. We have set values for name, company, and age of this employee object here. But we also said that we can describe behaviors as well. So how can we describe a behavior of an employee? Let's first think of a behavior that an employee has. Let's say, for example, that he can introduce himself. So he comes to work and he says, hello, my name is so-and-so, I work for this company, and I am 25 years old. So how can we describe that behavior in this class here? Well, we can describe that with a class method. And what a class method is It is basically a function. So we are going to create a function inside this class employee. So let's do that. I'm going to create a function of return type void, and I'm going to call that function introduce yourself, like this. Okay, and then inside this function, what I want to do is you can write, hello, my name is, and then you put this name, and then I work for this company, and I am 20 years old, for example. But I'm going to make it a little bit more formal, so I'm going to say the following. See out, and then I'm going to write out name, like this. Okay, and then let's put name, and I'm going to add end line, and then I'm going to write out these two informations as well. So company, and then paste here company, and then age as well. Okay, now how can I invoke this introduce yourself function? Well, the same way as we did here. I'm going to say employee, and then I put dot, and as you can see, this introduce yourself function is available here. So let's invoke that function like this, and now we should be able to test this. So if I run my program, okay, as you can see here, it says name Saldina, company YouTube Code Beauty, and then age 25. Okay, great. And now if we needed to introduce our employee 5 times, for example, we just copy this function 5 times, like this. And our user is going to introduce himself 5 times. And if we didn't have this class method here, we would have to copy this code 5 times. So each time that we want to introduce our user, we would have to copy this code here. Instead of doing that, we can create a class method which represents a behavior, and then we can invoke that class method whenever we need it. And if I run this program, this user should introduce himself 5 times. Okay, 2, 3, 4, and then, 4, and then 5. Okay, let's now delete this because I don't need it anymore, because I want to show you something else. So let's say that we want to create another employee in our program. So how would we do that? Well, we would use the same approach that we had here. So employee, the name of my class, and then employee, let's call it employee 2, which is going to be the name of the object. So let's assign the values for these attributes for our second employee as well. I'm going to say employee 2, like this. And his name is going to be John, for example, like this. Let's copy this 2 more times. So company will be Amazon, for example. John works for Amazon, and he has, let's say, 35 years, like this. Okay, so now if I want to introduce John, I'm going to say employee 2 dot introduce yourself. Excellent. So if I run this program now, as you can see, here is me, Saldina, YouTube Code Beauty, and then here is John, Amazon 35. Okay, now one problem that I already see here is this part of the code and then this part of the code. What would happen if we wanted to create 10 more users or 100 more users? We would have to repeat this for every single user that we create. And that is not really optimal, because there is a better way, there is a better approach of constructing our objects. And in order for you to be able to understand this, I will have to tell you a story about constructors. So now you may wonder, Saldina, what is a constructor? Well, a constructor is a special type of method that is invoked each time that an object of a class is created. So whenever you create an object of a class, a constructor is invoked. So does that mean that here and here as well, a constructor is invoked? The answer to that question is yes. Now you may wonder, okay, we have not created any constructor, you must be lying. Well, let me demonstrate you something. Let's comment this code here. And then let's comment this code here as well. And let's see what will happen if I run my program. So we are not assigning any values to the attributes of this employee nor this employee here. So if I run my program, okay, here is what happens. As you can see, this is our first user and this here is our second user. So here we don't have anything, and then here we also don't have anything, and then here is a number which I am not going to try to read, okay? But basically, this here is the work of default constructor. So what is default constructor? Default constructor is a term to describe a constructor that is automatically generated by your compiler. So in case that you don't create a constructor of your own, your compiler is going to automatically give you a constructor, which is called default constructor. Okay, now let's stop this and let's see how we can create our own constructor, because those values that you saw, that is something that we cannot work with. I mean, we don't want to work with those values. We want to use our own values. We want to use this, and then this here, and for our second user, we want to use these values here. So how can you create a constructor of your own? There are a few rules when it comes to creating constructors. There are 3 rules, actually. So the first rule is following. We already said that a constructor is just a method, but unlike other methods, a constructor does not have a return type. So let's scroll this up, and as you can see, this method here, introduce yourself, this method has a return type of void, which is nothing, but we still have to specify that. But a constructor will not have this at all. So that's going to be the first rule. The second rule is that a constructor has the same name as the class that it belongs to. So the constructor of class employee will be called employee. So that is the second rule. The third rule is that constructor must be public. Now, this I'm saying as a rule at this level of knowledge because a constructor does not necessarily need to be public always. There are certain situations, specific situations, when you would want to make your constructor private. But at this level of knowledge, I would advise you to make sure that your constructors are public. Because if you remember when we talked about access modifiers and when we said what private means, that means that everything that is private is locked, is hidden inside your class, and you most definitely don't want to make your constructor hidden. So, 3 rules. The first one is that constructor does not have return type. The second one is that constructor has the same name as the class. So, let's create constructor of this class here. It will be called employee, and I am going to put that constructor in this public area, because if I decided for some reason to put this constructor, if I decided to make this private, let's make this private like this. As you can see, immediately here we get an error. So our employee 1 and then our employee 2, this error says employee constructor is inaccessible, and here as well, because we have made this constructor private and we cannot access it outside of this class here, and we do not want to do that. We want our constructor to be public. So I'm going to remove this private access modifier, and as you can see, this error here has disappeared now. So the job of this constructor here is going to be to construct the object of employee. That means that whenever we create employee, we want to pass these 3 values here. So name, company, and age. We want to pass that to our constructor here. So we are going to receive that in our employee constructor as parameters. So I'm going to say string name and then string company like this and int age. Okay. Now that we have received these 3 parameters here, what I want to do with them is I want to assign them to these 3 properties here. So I'm going to say name of my employee will be this name here, like this, and then company that our employee works in, it will be this value here. So company, and then age, like this, will be whatever we passed as this parameter here. Okay, and now if you look at our employee, here we have an error again. So let's check what that error is. it says no default constructor exists for class employee. So what this error here means, it means that when we decided to create our own constructor, at that moment we lost the default constructor that was automatically generated for us. So when you decide to create your own constructor, you are going to lose that default constructor, and you can fix that by either making your own default constructor or by providing here these three values that we have specified that our constructor is going to receive. So let's do that. Let's provide here name, company name, and age. So how do we do that? Well, let me show you how we can use this constructor here. So in this line, I'm going to say that my employee 1 is going to be equal to, and I'm going to invoke this constructor basically. So I'm going to say, hey, I am invoking this constructor here, and here it expects to receive argument list. What is argument list? It is these three parameters. So name, company, and age. So here I'm going to pass name, which is Saldina, and then company is going to be this company here. So YouTube Code Beauty, I'm going to copy that. And then age is going to be 25. Okay, so with this, we have successfully constructed our employee 1 object, which means that I can delete this code here. And then if we do this same for our employee 2, we will be able to delete this code here as well. So let's do that. I'm going to say employee, and then here I want to pass these three values. So name is John. Okay, and then company is Amazon, like this, and then age is 35. Excellent. So I am able to delete this as well. And let's check what is going to happen if I run my program. I'm just going to format this. So if I run my program, nothing should change. I should still be able to introduce this user and then this user as well. So let's do that. Let's run our program. Okay, and as you can see, Saldina, YouTube Code Beauty, and then 25, John, Amazon, 35. So now we have managed to reduce the code that we had in our main function to only 2 lines per employee. So the first line is to construct that object, and then second line is to introduce that user. And we have managed to do that with our employee constructor, which is now doing that work of constructing the object based on the parameters that we pass to that constructor. That constructor receives those parameters here, and then it constructs the object here. It initializes the values of that object, and then in our introduce yourself function, whenever we invoke that function for an object of an employee, that function is going to do this code here. So it is going to basically introduce that employee. So I hope that this part so far was understandable for you, because here I'm going to take a quick break and I'm going to pause the video, and then I might be back in a couple of minutes or in a couple of hours or even in a couple of days, but that is going to be just a couple of seconds for you. And I want to make a transition that I never did on my channel. I never did this on Code Beauty, but I'm going to do it here, and that is this transition here. Whew. Hello and welcome back. And let's continue talking about object-oriented programming. But before I continue, I want to make a quick summary of the things that we have learned so far in this course. So first, I have explained what is object-oriented programming and what is the main idea behind object-oriented paradigm. And then I have explained what are classes and what are objects, and how you can use those classes and objects in order to represent real-life entities together with their attributes and their methods in your programs, describe them to your computer. And then we have also talked about access modifiers, so private, public, and protected. And then we have seen what are constructors and how you can create and use constructors. And now the time has come to talk about 4 most important principles, 4 pillars, 4 most important concepts of object-oriented programming. And those are encapsulation, abstraction, inheritance, and polymorphism. So the first one that I want to talk about is encapsulation. So what is encapsulation? The idea of encapsulation is idea of bundling or tying together data and methods that operate on that data so that they are grouped together within a class. And why do we do this? Well, we do this with the purpose of preventing anyone or anything outside of our class to be able to directly access our data and to interact with it and to modify it. So, I am not saying that we don't want anyone to access our data at all. I'm just saying that I don't want that to happen directly. I don't want that other class to be able to directly modify and change and interact with my data, because I want to provide my own way for that to happen. So how do I do that? How do I provide a way for other classes to interact with the properties of my class? Well, I provide very specific public functions that that other class can invoke and in that way interact with my data. So again, how do you access encapsulated properties of a class? The answer is through its methods. And these methods are very often implemented as getters and setters. So now I'm going to show you in code how those getters and setters look like and how we can modify this program that I have here so that we obey that rule of encapsulation. So the first thing that I want to do here in this program is I want to make these three properties, I want to make them private. So I want to encapsulate these three properties, hide them within this class. So let's do that. Here I'm going to put private modifier. So this here is private access modifier, and we don't actually have to write this because everything that does not have a modifier at all in C++ is private by default within a class. But I just find it more readable if I do it this way. So now here in this private area, I am going to move these three properties. Okay, and then paste them here like this. And now we have hidden these three properties within this class called employee, which means that now we will not be able to access these three properties anymore outside of our class. Let me just collapse this and let me prove you what I just said. Okay, so if I try to access name or company or age on my employee object, I should not be able to do that now. So if I type employee1, for example, and then I type this dot, you can see that the only thing that we can access is this introduce yourself method, which is this one here, and that is the only thing that is public besides this constructor here. So how can we access these properties then? Well, as I said, we have to expose our own methods, which are going to be public, and then by using those methods, other classes and other users will be able to interact with this data here, with these three properties. So let's create getters and setters for these three properties. Let's first do it for our name property. So I'm going to do it here. Let's say void set name. And then what this method, what this function is going to receive, well, that is going to be a string name. Okay, string like this. And then once this function receives this parameter called name, what I want to do with this is I want to assign this value to this property here. So I'm going to say name is equal to name. Okay, and then I want to create, so this here is a setter, and then I want to create a getter method as well. So I'm going to say string get name like this, and then here I'm just going to say return name. Okay, now this method here receives one parameter, which is called name, and then it sets the value of our property, which is encapsulated, which is this one here, to that value that we have received in this setter. And then this method here, getName, that method is going to return the value of our name property that is also encapsulated, and that value is going to be returned to whoever invokes this method. And because these two methods are public, anyone outside of our class is going to be able to invoke setName and getName. So these are examples of setter and getter, and now I'm going to do the same for our company property and age property, and I will be back to show you that code in a moment. So I have created getters and setters for our name property here. So this is setter, this is getter for our name property, and then here is a setter for our company, and then getter for company property, and then here are setter and getter methods for age. And now, because these methods here are public, everyone outside of our class should be able to access these methods, whereas these three properties are now encapsulated, which means that they are private, they are hidden within this class, and no one else besides members of this class here are going to be able to access them directly. So let's test now these getters and setters in our main function. Okay, so let's say that employee1, and let's say set age, and I'm going to say, for example, that my employee1 now has, let's say, 39 years, for example. Okay, and in order to test these getters, I'm going to say, for example, std cout, and then let's say employee1 dot get name. Okay, so our getter should work like this, and then let's say employee1 is, and I'm going to test if this value has been applied successfully. So I'm going to say employee1, oh, what is this? Employee1 dot get age. Okay, and here I want to say employee1 is 39 years old, like this. Okay, and now if I run this program, we should get the result of this line here, and we should be able to see if our getters and setters work as they should. So let's run our program. Okay, and now this last line of code here says Saldina is 39 years old. Okay, so I shouldn't have done this for myself. I should have done this for John, for example. So I'm going to close this program, and as you could see, these get name and get age and also get company and then setter methods as well are now public, whereas the properties that they are hiding are hidden within the class and they are encapsulated. So the only way to access these three properties is going to be using these methods. Now what we can do with these methods is we can provide special rules to interact with this data here. For example, let's say that employee cannot be anyone who is not older than 18 years old. So here, when I'm trying to set the age of our employee, I'm going to add a check. So I'm going to add a validation rule, and I will say if age, this age that I have received in my setter, is greater than 18 years old, or actually greater or equal to than 18, because person that has 18 years old is of age. Only in the case that this property here is greater than 18 years old, only then I am going to assign that to my age property here. In the case that our user, anyone else, decides to assign value which is less than 18, so 17 or 15 or 10 or whatever, I am not going to apply those changes. So let's test this also. Here, instead of setting age to 39, I'm going to say that Saldina now is 15. So let's test those changes. Okay, and now, as you can see, it says Saldina is 25 years old. Why? Because this set age method here says that only valid age is 18 or greater than 18, and only in that case those changes are going to be applied. Okay, so you can apply certain validation rules to your setter methods, and then I'm going to leave to you to apply certain validation rules to your set company name and then set employee name, this property here. So you can do that as a homework. You can decide if you want to allow only letters or you want to allow also numbers and special characters as the name for your employee and then as the name for your company. Okay, so once more, the idea of encapsulation is to make this, let me close this. So the idea of encapsulation is to make these properties private, and then whoever wants to access these properties outside of this class will have to go through the methods that you expose that do have access to your private properties. Okay, so let's collapse this. And here are those 6 getters and setters for these 3 properties here. The second principle that I want to talk about is called abstraction. What is abstraction? Abstraction means hiding complex things behind a procedure that makes those things look simple. So in order to explain this, let's use an everyday life example. Let's use the example of your smartphone. So one of the main characteristics that smartphones have these days is that they can take pictures. So how does that procedure of taking a picture looks like? Well, it's pretty simple, at least on your side. You just press a button and you have taken a picture. Or you press a button and then you make a call or you send a message. But that is not really that simple, because for you it is just a button click. But for the company that makes those smartphones, there is much more complex logic that they need to implement in order for you to be able to press a button and then take a picture. So there is some sort of interface between you and then that company that produces those smartphones. So on your side, everything is pretty simple and easy. You just press a button and you make a call. You press a button and you send a message. But then all of that complexity behind those functionalities is hidden from you, and that complexity is on the side of the company that produces those smartphones. Now, all of this complexity that is hidden from you, you don't actually need to know anything about this in order to be able to use this side here, in order to be able to make calls and send messages and take pictures. So what happens if another company comes and they decide that they want to produce smartphones as well? What they have to do is they have to sign this contract here. They have to provide you as a user with this nice and beautiful and clean and simple interface so that you are able to press a button and take a picture. And then they have to take care on their side to implement all of that complex logic, which is hidden from you, because if they decide to show you that ugly side, that complex side, chances are that no one is going to want to use their smartphones at all. And even if someone decides that they do want to use their smartphones, they will probably not understand this complex logic well, so they will make mistakes and they will use those smartphones in wrong ways. So this process of hiding that complexity from you as a user is called abstraction. And in that way, this very, very complex system is hidden, and this system here is represented as very simple system by this contract. So let's see how we can implement this contract here that makes one side look simple and then other side very complex. Let's implement that on the code and example that we have here in our Visual Studio. So let's take a look at this employee class here. What kind of functionality, complex functionality, can we implement on this class here? Let's say, for example, that every employee can ask for promotion. So he goes to his boss and he says, "Hey boss, can I get a promotion?" And then his boss needs to go through this very complex thought process in order to decide if this person deserves a promotion or not. So his boss needs to consider many things. He needs to consider, for example, how long this person has been working for the company, how much knowledge this person has, and then what kind of relationship this person has with their colleagues, how much this person is contributing to the company. And then, is this person always late for work? Are they breaking deadlines? And many, many more things. So how about abstracting that functionality? And in this situation, we are doing that for another developer that is going to use our class. So here in this situation, we are the ones who are making this class. So we are producing that smartphone. So we are the ones who should provide that complex logic for those functionalities that are complex, and then we should provide that simple and basic interface for anyone who wants to use this class here. So how do you do that? How do you create that contract? Well, the answer is by using abstract classes. For those of you who are coming from C# or Java world, there is already this concept of interface that some of you might be familiar with, and in C++ you can simulate behavior of interface by using abstract class. So let's create an abstract class. So here on the top, I am going to create a class, And let's create a class called abstract employee, like this, or you can call it employee if you want. So this class here is going to serve as a contract, and this contract will have only one rule, and that rule is that whichever class decides to sign this contract, that class will need to provide implementation for a method called ask for promotion. So a method of return type void called ask for promotion, like this. And we are also going to make this obligatory, which means that we will force any class that signs this contract here to implement this method here. So how can we make this obligatory? The answer is by making this function here a pure virtual function. So I'm going to say here virtual, and then here I'm going to say is equal to 0. And now this class here has become an abstract class, and this method here, this function, is pure virtual function or an abstract function. And this means that whoever decides to sign this contract called abstract employee, that class that signs this contract will have to provide implementation for this method here. So now the question is, how can my class, my employee class, sign this contract here? The answer is pretty simple. You add here column sign, and then you specify the name of your contract, which is abstract employee, like this. Okay, and now my class has successfully signed this contract. And immediately, if you could notice these two red dots that appeared below, if we hover over these errors, because these are errors, you can see that it says pure virtual function abstract employee ask for promotion has no overrider, which means, hey, you signed this contract here, but you are not obeying the rules of that contract. You are not providing implementation for this function here. So in order to avoid these errors and fix these errors that we have now, what we have to do is we have to provide implementation for this method here. So let's do that. Okay, I am going to copy it here, and then I will come here and paste it, and here in these curly brackets we are going to implement that method. But as you could see, immediately the errors that we had below have disappeared. So here inside this class I want to provide logic for ask for promotion method. So once more, we said that that logic is pretty complex and that we should take in consideration many things. So things like how long that person has been working for a company, how much that person is contributing to the company, what kind of relationship they have with their colleagues, and so on. But considering that we don't have all of that information, what I'm going to do is I'm going to make it a little bit more simple. So I'm going to say, for example, any employee that is older than 30 years old can get a promotion, for example. So I'm going to say here, if age is greater than 30, I will do the following. I will say std cout, and then let's write the name of this employee. I'm going to say name, and I'm going to say got promoted, like this. Okay, excellent. And then in the else case, so in the case that person has less than 30 years, I'm going to write something else. So I'm going to deny that promotion to the person who is younger than 30. So I'm going to say name, and then let's write out, sorry, no promotion for you. Okay, excellent. And now let's test this method here. So I'm going to go to my main function, and I will delete all of this code here. Okay. And now I want to test this method here on my employee 1 and employee 2, so that I see if any of them can get promotion. So let's say employee 1 dot ask for promotion, and then employee 2 dot ask for promotion as well. And if I run my program, it says, Saldina, sorry, no promotion for you, and then John got promoted. And why that happened? Because, let me close this, because Saldina is 25 and then John is 35. And this rule here says that whoever is older than 30, which is John, he gets promoted, and then if that person is younger than 30, that person is not going to be promoted. Okay, so with this we have accomplished the following. We have implemented a contract, which is actually an abstract class. And that abstract class or that contract has only one rule. And that rule is this pure virtual function here, which is called ask for promotion. So that means that whichever class signs this contract, whichever class inherits from this abstract employee, which is this class here, that class will have to provide implementation for this method here. So ask for promotion. So in this situation, our employee is inheriting from our abstract employee. So our employee class is signing that contract, which means that that class needs to provide implementation for the method that is in that contract. Okay, now what this allows us to do, when another developer comes to our code and wants to use our employee class, that developer will see this contract here and he will say, oh, so this employee class has method which is called ask for promotion. So that means that if I use employee class, I can invoke this method here, and I don't need to worry about complexity of this method. I don't need to worry about how this promotion is given or rejected, because that is the worry of the person who implemented this class here. So that is the worry of the person who is going to sign this contract. And in this situation, we are that person. We are the person who is producing that smartphone. We are the person who is writing this class, and this class is signing the contract, which means that we have to provide implementation for this method here, as we did in this situation. And we tested it, and as you could see, I didn't get promotion and John did. So that is the idea of abstraction, and this ask for promotion method is just that button that we mentioned, a button on your smartphone from the beginning of this chapter. The third principle of object-oriented programming that I want to talk about is called inheritance. The idea of inheritance is the following. So there is this base class, also known as superclass or parent class, and then there is derived class, also known as child class or subclass. Now, this base class here, this parent class, has certain attributes and behaviors. It has members. And then if this class here decides to inherit from the base class, at that moment, this class becomes a child class, and by that, this class is going to obtain all of the members of this base class here, which means this class is going to have all the same attributes and behaviors as its base class. And then this derived class can also have its own members that are specific for that class only, which this class here does not have. So in order to explain this, let's use an example that is going to be familiar to you. Let's return to the example of a car that I used in the beginning of this video. So a car as a class is going to have certain attributes. For example, a name, a model, price, a color, and so on. And then it is going to have behaviors as well. For example, it has a method called drive. Now, what kind of derived classes can we create from this base class? What kind of classes are more specific? So what kind of car types are more specific than just car? Let's say, for example, that we are going to have one derived class that is called electric car, and then another derived class which is called conventional car or gas car. Now, this electric car is also going to have all the same properties that a car has. So it is going to have a name, a model, a color, a price, and then it is going to have a method called drive. And then this conventional car is also going to have all those same properties: but they are going to be different between them. This car, for example, is going to have a method called charge because this is electric car and we need to use electricity to charge it. And then it is going to have an attribute called, for example, battery status. And then this car, which is gas car, conventional car, is going to have a method called tank, which means a method of putting fuel in that car. And then it is going to have a property, an attribute, which is named tank status, which shows you how much gas do you have left in your tank. So each one of these derived classes is going to have their specific attributes, but they will also inherit all of those attributes that their base class has. So now let's see how we can implement that on the example that we have here. So here I have a class called employee, and what I want to do is I want to create a derived class for this class here. So what kind of class can inherit from employee class? Logically, what is more specific type of employee? Let's say, for example, that we want to create a class called developer. So let's do that. Here I'm going to say class, and then let's call this class developer. Like this. Okay, so with this, we have created a class called developer, and now what I want to do is I want to make this class inherit from this class here. So how do you do that? The answer is pretty simple. You put column sign here, and then you specify the name of your base class, and the name is employee. So with this, a few things happened. This class here, developer, became a child class, which means a subclass or derived class, and then this class here, employee, is now called base class or superclass or parent class. And also another thing that happened is that this developer class here now has all of these properties, and then these ones here as well, that our employee class has. So developer has all of the properties that employee has, and then let's create one more property that is going to be specific for developer only. So I'm going to make that property public. So here I'm not obeying the rules of encapsulation. You can do that for homework, for example. So let's create a property that only developer has, but employee does not. That is going to be, for example, favorite programming language. Developer has favorite programming language, but an employee does not necessarily have to be a developer, so he does not necessarily need to have a favorite programming language. So I'm going to say string favorite programming language. Like this. I hope that I didn't make a typo here. So now let's check if everything that I said is correct. So if this developer indeed has access to all the properties that our employee has, and then to this one here, which is specific for developer only. So let's delete this code here, and then I want to create an object of class developer. So I'm going to say developer, and let's call that object D, like this. Okay, and the first thing that happens is we get an error, and it says, okay, it says default constructor of developer cannot be referenced. So this error here is happening obviously because we don't have a default constructor. And if you remember, when we were talking about constructors, we said that every class, when you create it, every class has automatically generated default constructor. But once you decide to create your own constructor, you lose that default constructor. So now you may ask, well, Saldina, we have not created constructor for this developer class. And I'm going to say you're right, but we have inherited from employee class, and that employee class has a constructor that we created. So that means that we need to provide a constructor for the derived classes of employee class, which is our developer class. So now what I'm going to do is I'm going to create a constructor for developer class. So if you remember 3 rules of creating constructors. First rule is that it does not have return type. Second rule is that it has the same name as the class. And then third rule is that it needs to be public. So I'm going to call this constructor developer, like this. Oh, sorry. and then I need to put these curly brackets here. Okay, so now the job of this constructor here is going to be to construct developer object. And considering that this developer object inherited from employee class, that means that developer has these properties, so these attributes, and then this one which is specific for only developer class. So now we have to provide this constructor with those parameters. So I'm going to copy these three here because I already have them, and then paste them here. And then I will add this parameter which is specific for developer class. So I will say string language. Like this. So this is favorite programming language, or actually let's call it favorite programming language so that we are consistent. Okay, now once we have passed these four parameters to our developer constructor, what we have to do is we have to initialize this attribute here and then these three attributes here, because those are attributes that our developer class has. But one thing that I want to show you is following. Considering that this developer class is inheriting from employee class, and that employee class has a constructor of its own, which is this one here, that constructor already knows how to construct name and company and age. So that means that we don't have to worry about these three properties in our developer class. We should only worry about a specific properties of our developer class. And these three properties that actually belong to our employee, we can pass these three to our employee constructor. So I'm going to do that like this. Here, so after this parentheses, you put a column sign, and then you specify the name of that constructor, so employee. So the name of your base class, and then here I will pass these parameters that our base class constructor receives. So name, and then company, and age. Okay, so now this constructor, the constructor of our base class, is going to take care of these three properties, and we are left with this property here, which is specific for our developer class. So here I want to initialize our favorite language property. So I'm going to say that favorite language is equal to whatever has been passed to this constructor. Okay. Now if I go down there to my main function where I tried to create my developer, let's try to construct an object of type developer. Let's try to invoke this constructor here like we did in this line here and then in this line here for our employee. So I'm going to say that a developer is going to be equal to developer, and then here I want to pass values for this constructor here. So those are name and company name and age and favorite programming language. So let's call this developer also Saldina. I'm going to delete these two because we will not need them anymore. Okay, and then let's say that I work for YouTube, Code Beauty, and then I am 25 years old and my favorite programming language is C++, for example. So now that I have successfully created an object for developer class, let's test this. So how am I going to test this? Well, let's create a method on our developer class that is going to use some of these values here so that we can know if these values have indeed been set successfully. So what kind of method can we implement on developer class? For example, we can implement a method called fixBug. So I'm going to do that. Let's collapse this constructor and let's say here void fixBug. And then what I want this method here to do is I want it to say Saldina is fixing bug using C++, or Saldina fixed bug using C++. So here I'm going to do that. I'm going to say std cout, and then in order to access the name of this employee, I'm going to use getter. So I'm going to say get name, which we created previously. And then here I'm going to say fixed bug using, and then let's use this programming language here. Like this. Okay, And now if I want to test this method here, I can invoke it on my developer class. So I'm going to say d.fixBug, and if I run my program, as you can see, this method here works, and then the values that we passed in our constructor have successfully been set. So here it says Saldina, and then fixed bug using, and then here is my favorite programming language. Okay, let's close this. And now there is one more thing that I want to show you, and that is this part here. So I want you to notice that this here is the way that we are using in order to access properties of our employee class, and then we are accessing directly properties of our developer class. So can I access properties of my employee class directly? Can I access this property here, for example, name, or do I have to access it by using getter? Write me your answers in the comments down below. So I am going to test that now. Here I'm going to say name, and we get an error. It says employee name is inaccessible. So we cannot access this property here, name, which is the property of our employee class. Why? Well, if you remember when we were talking about access modifiers, we said that whatever is private, that is going to be locked, hidden, that is going to be accessible only inside that class. And then whatever is public, we will be able to access that outside of the class. So how can I make this property here? How can I make this name accessible in the derived classes of this class here? Again, when we were talking about access modifiers, we said that there are three of them: public, private, and protected. And I promised you that I am going to explain what protected access modifier means. So in this situation, if we make this property here, if we make this name property protected, that will make name available in derived classes of this employee class here. So I am going to say protected like this, and then I'm going to take this property and I will move it to my protected area. And then if I return to my developer class, as you can see, the error that we previously had is now gone. So now this name property is accessible directly from this derived class here. And if I run the program, it should work the same as it did. And as you can see, it indeed works the same. So Saldina fixed bug using C++. Okay, now there is one more very important thing related to inheritance that I want to show you, and that is the following. Let's say, for example, that this developer here fixes a lot of bugs. So if I run my program, you can see that Saldina indeed is fixing a lot of bugs. So what this developer here decides then is he or she, in this situation she, decides to ask for promotion. So I'm going to try to do that now. I'm going to say d dot, but if you look at the list that I have here, it only has the access to favorite programming language and then fix bug. So if you look at this, you can see that I don't have access to the other properties that I have inherited from my employee class. I do have access to them here, so if I try to invoke them in this method here, so if I say here, for example, ask for promotion, as you can see, I do have access to them here, but as you could see, on my developer object, I cannot access those properties. So how can I fix that problem? Well, the answer is pretty simple. This inheritance here, so this part of the code here, this inheritance is private by default. And in order to fix the problem that we have, we need to make it public. So here I'm going to say public, and the problem should disappear. So if I return to my developer object now, and if I try to ask for promotion, as you can see, that method is available. So maybe I'll get a promotion this time. Let's test this. And unfortunately, I am not getting a promotion, but at least my code is working. So now we have access to this method here, which is implemented in my employee class, so in my base class. And we have achieved that by making this inheritance public. So while we are talking about inheritance, let's create one more class that is going to inherit from this employee class. So let's create one more derived class besides this developer. So what kind of class can inherit from employee? What is more specific class than employee? For example, let's create a class called teacher. So here I'm going to go one more time through this process of creating derived class. So I will say class, and then I will call it teacher, like this. Okay, and with this we have successfully created a class called teacher. And now what I want to do is I want to inherit from my employee class, like this. Okay, and then what I need to do is, let's first create some specific attributes for my teacher. So let's say, for example, that a teacher has attribute called subject. So this here is the subject that my teacher is teaching. And then let's say also that the teacher will have a functionality that is going to be specific for this class only, and that functionality will be called prepare lesson, for example. So I'm going to say void prepare lesson, like this. Okay, and what I want to do here is I want to do something like this. So I want to say, for example, the name of that teacher, and then I want to say that he or she is preparing lesson from this subject here. So let's delete this empty space. So I'm going to say std cout, and then let's put the name of my teacher. So name, like this, and then let's say is preparing, and then here I want to put the name of my subject, like this, and then let's add lesson. Okay, now there are a few problems that we have with this class here. The first problem is that these here are private, which means that we will not be able to access them outside of this class here, because everything inside the class is private by default. So that is going to be the first problem, and let's fix it. So I'm going to say public, like this. Okay, now second thing that is going to be a problem for us is that this teacher class here does not have a constructor. So if I try to create an object of type teacher, I will not be able to do that. So let's demonstrate that error now. I'm going to say teacher, like this, and let's call it t. And well, if I do this only, we should get an error which says default constructor of teacher cannot be referenced, which means that we need to implement a constructor for this class here as we did for this class here. So as we did for our developer class. So let's do that. I am going to create a constructor called teacher, like this, and then this teacher constructor will receive these three properties that our employee has, like this, and then it will receive another parameter called subject. Okay, now this constructor is going to pass these three properties to constructor of base class, so this one here. Let's do that. Let's say here employee, and then inside I will pass name and company and age, and then here this teacher class will take care of constructing this part. So I'm going to say that my subject is equal to this subject that we received in our constructor. Okay, and now if I return down here and I try to make a teacher, let's name the teacher Jack, for example, and he is going to work in a school called Cool School, if such thing exists. Okay, and then he's going to be 35 years old, and he is going to be history teacher, for example. Okay, now we have successfully created our teacher Jack, and I am going to collapse this, and then I want to test this method here. So I am going to say teacher t dot, and then prepare lesson. Okay, and if I run this program, it says that Jack is preparing history lesson. Okay, And then one more problem that we have with this class here is that our teacher T does not have access to properties of our employee class. So if I type T dot, as you can see, it has access only to these two properties. So in order to fix that problem, I am going to add public here. Okay, and if I try to make Jack ask for promotion, let's see if Jack gets the promotion, because I didn't get promotion. Okay, it says Jack got promoted. Excellent. And I didn't, and that is because Jack is 35 years old and I am 25 years old. Okay, so if you don't know what I'm talking about, you will have to return to the part where we are talking about encapsulation, I believe. Okay, so that was the story of inheritance. We created two derived classes. One is developer and the other one is teacher. And those two classes are inheriting from a class called employee, as you can see here and here. And we will be using these classes in our next example to explain our next concept, which is polymorphism. As I said, fourth principle of object-oriented programming is called polymorphism. And this is the one that I see people struggle with the most for some reason. I don't know why, because it is pretty simple and cool, as you will see. So it is very simple, but only if you understand the things that I have explained so far in this course. So the first thing that I want to explain is what is polymorphism. The word itself comes from Greek language, and it is a compound of poly and morph, which means many forms. And in programming, polymorphism describes the ability of an object or a method to have many forms. Now, the most common use of polymorphism in programming is when a parent class reference is used to refer to an object of a child class. Does that sound a little bit complex when I say it like that? I believe that it does, and I agree. But stick with me for a couple of minutes and let me show you how simple this really is on the example that we have here. So in order to explain how polymorphism works, let's return to our employee class. So this one here, I'm going to collapse this, and then what I want to do in my employee class is I want to implement one more method. And let's call that method work. So I'm going to say void work, and then here in this method, what I want to do is I want to say, for example, cout, let's say name of this employee, and then let's say that that employee is checking email, and then he is checking also task backlog. Okay, it's backlog. Okay, task backlog, and then he is performing those tasks. And so on. Okay, and let's add end line. Like this. Okay, now let's return to this main function here, and what I want to do is I want to invoke that do work method that I just implemented. And I want to invoke that method on this developer and teacher class, because considering that developer and teacher are inheriting from that employee class, we should be able to do that. So if I say d.work and then t.work, let's see what will we get if I run this program. Okay, it says here Saldina is checking email, task backlog, performing tasks, and so on. And then Jack is also checking email, task backlog, and performing those tasks. Okay, but one thing that I don't like is I don't like me checking emails and checking task backlog and so on. What I like is I like to write code. So how about implementing this work method on my developer class as well? So let's return here to my developer class, and what I want to do here is I want to copy this method like this, but instead of checking email and checking task backlog and so on, what I want to do here is I want to say that I am writing code. So let's say Saldina is writing, and then let's put this programming language here like this. And then let's say code. Okay, and now I'm going to do the same for this teacher class here. So let's copy this method and then paste it in my teacher class, but instead of writing code, teacher is going to be doing something else. So what teacher does? Well, teacher teaches. So I'm going to say the name of my teacher, which is Jack in this situation. So Jack is teaching, and then let's put the name of his subject, which is history, I believe. Okay, now one thing that you must notice is that this work method has the same name here and then here as well, and it also has the same name in this base class, so it is called work. But the implementations of this method, this work method, are different. Here it says that an employee is checking an email and checking task backlog and so on, and then developer has also its own implementation, which says that developer is writing code because that is his work, and then teacher is teaching his subject, which is his job. So I have here invoked these two work methods, and let's see what will happen if I run my program now. Okay, now it is better. It says that Saldina is writing C++ code and Jack is teaching history. Okay, now let's make one small improvement to the code that we have here, or actually two improvements. And the first one is going to be this writing with double T. Okay, what is this? This is criminal. And then the second one is going to be the rule that I mentioned in the beginning when I said the most common use of polymorphism. So let me copy that definition here, and then we will implement it literally word by word. So here it is, and it says the most common use of polymorphism is when a parent class reference is used to refer to a child class object. So let's see what this means in practice. I'm going to delete these two lines because I don't need them anymore. And then what I want to do is I want to create a pointer of type employee, like this. And one quick disclaimer, if you are not familiar with pointers, I am going to refer you to my channel, which is Code Beauty, where I have an entire playlist which is dedicated to pointers, so make sure to watch that, and then you can continue with this example here. So again, I have created an employee pointer, and what I want to assign to this pointer is not going to be an employee object. So I want to assign to this pointer here a reference of this developer and then this teacher class. So here I'm going to say you are going to hold a reference to this developer here. And this here is the rule. So a pointer of base class, which is this here, can hold reference to derived class object, which is this part here. So that is just the rule. Why? Well, because this developer here, this developer is deep down inside, it is an employee because developer is inheriting from employee, as we already could see in the previous examples of this course. So now that I have done this, let's do the same for our teacher. So I'm going to copy this line, and then here I'm going to name this employee 1, and then this is going to be my employee 2. And here I will say that employee 2 will hold the reference of my teacher here. So now what I want to do and what I want to achieve with this is the following. Wouldn't it be nice if I could do something like this? So employee1 dot work, okay, and then employee2 dot work. And this symbol here is used when you want to access members using a pointer. So instead of dot symbol, when you use a pointer, you use this symbol here. Okay, so wouldn't it be nice if this here worked? Well, let's see, maybe it does. If I run my program, as you can see, it again says Saldina is checking email and task backlog and performing tasks and so on, and Jack is doing the same, and he's a teacher and I'm a developer. So that means that this here does not work. But if you only knew how close we are to making this work, you are literally missing only one tiny little thing that I didn't tell you to make this here work. So what that thing is, Well, let's return to our employee class and then here, this work method. Let's make this work method virtual. So I'm going to say virtual here. So let's run our program now. And as you can see, it says Saldina is writing C++ code and Jack is teaching history. So it works. Wait, I have to explain this. Okay. So let's return to our employee class to explain what just happened. Well, look at this function here, this virtual void function. This function with this virtual keyword is known as virtual function. And what that means, well, it means that when a virtual function is invoked, it says, hey, can you please check if there is implementation of this function in my derived classes? And if yes, please execute that instead. So what ends up happening is that the most derived version of this function here is going to be executed. And that is this function here for developer and then this function here for teacher. So does that mean that if we didn't, for example, have implementation of function called work in our developer, that our developer then would do this that our employee has in its work function? The answer is yes. So let me comment this just to demonstrate how it would behave. So now I commented implementation of work function in my developer class. So if I run the program now, as you can see, it says Saldina is checking email and task backlog and performing some random tasks, and then Jack is teaching. And this is happening because teacher class has its own implementation of work method, work function, but developer class does not. So here developer is going to execute parents class method work, which is this method here. So that's why I am checking email and task backlog and performing random tasks instead of writing C++ code. So let's close this and let's now return this. I'm going to uncomment it like this and let's run my program once more. And as you can see, everything works again and we have this polymorphic behavior. So that, ladies and gentlemen, is polymorphism. So let me give you one little tip of what we can do with this knowledge now. So let's close this and I'm going to return to my main function. And here, as you can see, here we are creating a base class pointer to a derived class object, which is in this situation developer, and then in this situation it is teacher, and then in some other situation it can be some other type of employee. So if we created more derived classes, which we could do, we could create, for example, derived class called bus driver or pilot or singer or actor, doctor, and so on. And then we could keep objects of those derived classes like this. So we could reference them with this base class pointer because they would derive from employee as well. And then imagine a situation where you had 100 or 1,000 or even 10,000 employees. And then you are storing those like this, like we did with our developer and our teacher. And then you could literally in one line say employee.work. And what would happen is that all of those different types of employees would start doing their own job. So painters would paint, singers would sing, actors would act, doctors would talk with patients or something, I don't know. So that is the most beautiful thing that we have achieved with this here. So I hope that you enjoyed this video. If you did, give it a thumbs up. And then also, if you want more videos like this one, you can visit my channel, which is Code Beauty. And there I have a lot of videos related to programming and C++. And also leave me a comment. I would love to read something like, hey, I am coming from Pre-Code Camp or something like that on one of my videos. So thank you very much for watching. And I'm going to see you in some next video on this channel. And then if you decide to visit Code Beauty YouTube channel, I will definitely see you in one of my videos. Bye! So now I'm going to take a break for a couple of hours, but for you it is going to be just a couple of seconds because I'm going to pause the video here. And for this, I want to try a transition that I never did before, and it is this one. So what is polymorphism? The word polymorphism comes from Latin language and it means, or is it Greek?
$2,000 later.
I'm just going to skip this information. So if I hover over this, as you can see, we still have an error, but we have a different error, which means that we are making progress. Also visit me on my channel, which is Code Beauty, and subscribe there. And also leave me a comment. I would love to read something like, "Hey Saldina, I am coming from Free Code Camp and your course was great," or "Hey Saldina, I am coming from Free Code Camp and your course was excellent," or "perfect," or "outstanding," or something like that, you know?